Good day everyone. We all know the fact that Malaysia livestock industry is one of the fundamental industry in agriculture in Malaysia. It provide employment and basic needs such as dairy product. But how does this relate to our paddy field? In Malaysia, we are unable to meet the local demand for livestock. Various factors were affecting the supply chain such as poor private involvement, lack of land resources, and overpriced feedstock. Today, we are going to explore more on the alternate source of our feedstock. And for now, we will interview one of the farmer here, Mr. Wan.
Hi.
Hi, Mr. Wan.
For inviting me. Sure.
So, can I ask you the first question?
Okay, sure.
Okay. So the first question would be, for the time being, what will they do with the paddy straw?
Usually, we as a farmer, we have no restriction on what to do for the paddy straw. So for now on, we just burn all the paddy straw because it is the simplest way to clear our waste after harvesting the paddy.
Okay, this would be the last question. What do you think about the relation between paddy straw and livestock?
Okay, thank you. I think for livestock, what we can do for our abundance paddy straw is that we can take it and produce a new type of food pellet. And this is actually, I do believe that it can enhance our local poultry industry because by doing that, we don't need to burn all the wasted paddy straw, and actually it is good for us, local farmers.
Okay, thank you, Mr. Wan.
Okay, thank you, Miss Fitria, for inviting me for the short interview.
For this project, we have three objectives, which are to produce and supply pallet. The second one is to design a mobile paddy harvester, and last but not least is to enhance the pallet by adding supplement. So without further ado, we continue with paddy straw harvester concept generation.
There are 6 steps of concept generation being used in this project. The first step would be the selections of datum. We have selected 2 datum, which is Tucano Combine Harvester and the Rosa Mesh Nova 330. Most of the main components for both datum are almost similar with our project. We will use the datums as our reference. After selections of datum, the next step would be deciding on the physical decompositions of the project or choosing the main parts. As for the particular project, we have chosen cutter bar, reel, conveyor, grinder, and main body. Now, we have to decide the functional decomposition from its physical decompositions. The functions of cutter bar is to cut off the crops, while for the reel, will act as supporter to move the paddy straw towards conveyor. As for conveyor, it will become the transfer medium for the paddy straw to the grinder. Next, the grinder will cut into small pieces. Last but not least, the main body will support the whole system. For every part, we did a morphology chart where we have about 5 different types for each part. Then we will select based on our preference, especially from the costing and material perspective. The table shows only a part of our morphology chart. Another crucial section in concept generation is concept selection, where we use objective tree, weightage matrix, and part chart. These 3 steps will be the basis for final selections of morphology chart. The diagram is the finalizations of process flow after considering few methods mentioned before. We also did schematic diagram to show the overall concept of the paddy harvester. The last part of concept generation is schematic diagram before we can start with technical drawing.
Hi, welcome back everybody. So now I'm going to show you the main part of our conveyor. The first one is a cutter bar, and then the reel, and then we are going to the conveyor, and then the grinder, and the last one is a chassis as a main body. So now we are going to show the technical drawing that we prepared for about 3 months. This is our harvester that we named it as a pedestal. The focus of the drawing would be on the main part of the harvester, which is cutter bar, reel, conveyor, grinder, and the last one is a chassis. As for this project, the auger shown only acts as a support to direct the movement of the paddy straw to the conveyor. For this section, we will be explaining from the technical drawing perspective and the justification of the design. The first part would be the cutter bar that have 5 main components, which are cutter bar frame, auger, fixed blade, moving blade with motor, together with pulley. The design of the cutter bar is based on mechanism used and the arrangement of all the components. For moving blade, there are about 46 blades attached on a 3.5 steel bar using bolt and nut. The motor and pulley is used for slider crank as it is a mechanism to move the blade. As for fixed blade, it is only consists of 12 blades and the moving blade will be placed between the fixed blade. In order to make the moving blade stay on its path, there is a hollow on the steel bar of the fixed blade. The reel is in a pentagon shape and the length of it will be the same as cutter bar. For the rotation movement, the shaft will be attached to the same motor with the moving blade. The support on the both sides of the reel is to be installed beside cutter bar frame. The outer reel, as shown in the diagram, is to prevent the paddy straw from going out. Next is a conveyor where there will be 2 shafts to move the conveyor. The back shaft will be a driver where it will be connected to the shaft of the main engine. The front shaft will be driven by a back shaft using a V-belt pulley. The size of the conveyor is based on the power and the ability of the grinder to receive a paddy straw at one time. As calculated, the width of the conveyor is about 1.2 meter, while for the length of the conveyor is 2 meter. The 2 meter long of conveyor is to allow the grinder to grind the paddy straw in the right amount and to reduce the pressure of the equipment. Moving on to the grinder, which consists of 4 blades on one set with a diameter of 280 mm. There are about 28 sets of blades will be installed along 1.2 meter of shaft. The crucial part of the grinder is the blade, because the blade will operate in high pressure with high speed. Based on the datum, the blade used is square end, where it will provide an efficient cutting. Plus, the 4 blade will help the grinder to achieve the targeted output, which is 1 ton of paddy straw per day. The speed of the grinder is around 1000 rpm, where it will allow the paddy straw that have been grind to move out of harvester machine naturally. Among all the parts shown, the grinder has the highest power compared to the rest of the main component. The last component of our machine is the chassis. It is to hold all the components including engine, tire and driver seat. For the harvester to be stable, the most important part would be the weight of the chassis. As for the case, we are using chassis with a weight of 8,200 kg. Plus, soil in Malaysia is one of the factors that need to be considered while calculating the weight of the harvester. For our machine, we are using rectangular steel tube for the chassis. It is very crucial for the chassis to be able to support all the components so that the machine can be used without any technical problem. Now, I would like to introduce the founder of the pedestal, Ms. Nur Ain Sofian, to explain in detail about overall project costing.
Cost analysis are very important in running a business. Why? Because it can help you to determine your profit and how much your company should produce in 1 year. So, what is the first step in performing a cost analysis? It is to set up a study period, which in our company's case is 25 years. So, here is the summary of OPEX and CAPEX table of our company's cost analysis.
The OPEX or operating expenses of our company have been breakdown into fixed and variable costs, which are calculated on annual base. Our fixed cost consists of the payroll for the company's employees calculated per year, assuming that there would be no change on the rate. On the other hand, variable costs consists of costs that cannot be calculated due to uncertainties such as changing rates or price. For example, here we can see that utilities are listed as variable costs as the tariff price are not constant. By listing out all the annual expenses and summing that up, we can get an approximate of 1.5 million ringgit per year. Moving on is the CAPEX table. CAPEX can be simplified as the capital expenditures of a company in the long term, which in our case are the equipment and facilities. The first table summarizes the prices by part to produce 1 unit of our paddy harvester, which is in our case is 350,000 ringgit. Whereas the next table sums up the capital expenditures, which amounts to 1.03 million ringgit per year.
To sum up everything, this diagram will show you the cash flow of our company throughout the 25 years. By the end of every year, we expected that the total amount of revenue will sum up to 1.8 million, considering that we will sell 4 units for every year at the price of 450,000 ringgit. To know more on project management planning, our project manager, Mr. Haziq, will explain more on them.
Hi, I'm Mr. Haziq. So basically, time is very crucial in every company as every second wasted will lose you money. So therefore, project management planning is the heart of every company as it will help us to keep on track with the schedule with maximum profit and efficiency. Hence, this table lists out the main activities throughout the execution of this project. It consists of 18 significant events which are labeled in chronological order according to the process. Every activity is set with a certain amount of durations. The highlight of this table is the last column, the predecessor column. For example, here we can see A and B are listed in row C. This means that activity C can only be done once activity A and B had been executed, and so are the rest. We also perform a critical path analysis to determine the crucial activity in the whole process of our project. For Milwaukee paper, there is 6 components in one circle, where the top center is a symbol for the activity and below it is the duration. On the upper left corner represents earliest start or ES, while for the upper right corner is earliest finish or EF. For the lower left is represented as the latest start or LS, whereas for the lower right is the latest finish. Now the method to continue all the document is by using a two-step, which is a forward pass where it only considered ES and EF. It will start from the beginning of the activity. ES is the same as the EF of the previous activity, while the value for current EF is just by adding previous EF, which has the highest value with the current duration of the activity, and this will continue until the last activity. When it reaches the last activity, the second step will be introduced, which is the backward pass to determine LS and LF. It will start from the last activity where the EF and LF will be the same, and LS is the value of LF subtract with the duration. Next, LF is the minimum value of LS from previous activity, and it goes on until the first activity. After the completion of Milwaukee paper, slack time can be calculated to identify the criticalness of the path, which will affect the whole system if it is delayed. As for this project, only 2 critical activities in critical path, which is G, commissioning, and H, trial run. In conclusion, identifying activities and project timing is very crucial to ensure the project can be completed within time and budget. Now, I will pass to our host.
Hi everyone, now we have come to the end of our video. We can conclude that our product will be a great addition to the agriculture industry. Not only that, it will boost the poultry industry, but also can help save the environment, as the farmer no need to burn the paddy straw after the harvesting season anymore. By using high-end engineering and technology, our products are guaranteed to work with high efficiency. Cost analysis and project management are also being done to ensure that our prices are sold at a reasonable price befitting local farmers market. That's all from us. Bye!
Hope you guys enjoyed the video. Bye!
Bye.